All right, example 6, guys. Example 6I says, given that, let me see if I have space around here to work stuff out. Yes, I do. Given that f of x is equal to minus x squared minus 4x plus 5, we're to copy and complete the table below. Again, guys, the table below is called the table of values. We have values of x and we have values of f of x. So for the purpose of your graph, f of x would be your y-axis. So we have values of x and we have values of y. Some of the values of y are missing. The value of y when x is equal to minus 4, when x is equal to minus 1, and when x is equal to 2. So it's minus x squared minus 4x plus 5. So I have y is equal to minus x squared minus 4x plus 5. Now, the value of y when x is equal to minus, when x is equal to minus 4, minus 1, and 2 are missing. So I'm going to say when x is equal to minus 4. Guys, remember that minus x squared means minus times x times x. That's what it means. Many times persons forget and they always mess the thing up when they have minus x squared. But minus x squared means minus times x times x. The x alone is squared, the negative is not squared. So when x is equal to minus 4, y is equal to minus times x, which is minus 4, times x, which is minus 4, minus 4 times x, which is minus 4, plus 5. Over here, I'm multiplying 3 x's. And whenever you're multiplying an odd number of negatives, your answer must come out negative. So this is minus 16 here. A negative times a negative here is a positive. 4 times 4 is 16. And then plus 5. Minus 16 plus 5 is 5. So when x is equal to minus 4, y is equal to 5. Go back up to my table of values. So the value here is minus, sorry, not minus, is positive 5. When x is equal to minus 4, y is equal to 5. All right, so next we need to determine the value of y when x is minus 1 and when x is 2. So the same equation, y is equal to minus x squared minus 4x plus 5. I'm going to say when x is equal to minus 1, y is equal to minus 1 squared minus 4 times minus 1 plus 5. This is minus 1 because it is minus 1 minus minus 1 square means minus times minus 1 times minus 1. That's what it means, which is you're multiplying 3 negatives, so that must come out negative. So this here now is what? Plus 4, because a negative times a negative is a positive, plus 5. All right, this looks like it's going to work out to be 8. Same equation, y is equal to minus x squared minus 4x plus 5. I'm going to say when x is equal to 2, y is equal to minus 2 squared minus 4 times minus 2 plus 5. This is minus 4 because minus 2 square actually means minus times 2 times 2. That's only one negative, so that's just negative. Then plus what? 8 plus 5. 8 plus 5 is 13. 13 minus 4, I think, is 9. So 8 and 9 seems weird. Let's have a look at it. So it works out. So this is 8 here and 9 here. Something is wrong with this 9. Let's go back and fix it. I know what it is. It's not minus 2, it's positive 2. I know something is wrong. There's no way you can get 9 there. All right, so this is times 2 plus 5. This is minus 2 minus 8 plus 5. Sorry, minus 4. Minus 4 minus 8 plus 5. Minus 4 minus 8 is minus 12 plus 5. This is negative 7. All right. So we have negative 7. We have 8 and negative 7. So the value here is negative 7, which makes more sense. So you have minus 7. So it looks as if positive 9 is the highest value. And notice the numbers, the values of y to the right and to the left, they're the same. So it means that x equal to minus 2 will be your turning point. So let us now prepare our axes. The scale is 2 centimeters to 1 unit on the x-axis. So if it's going to be 2 centimeters to 1 unit on the x-axis, I need a minimum of 12 to the left. I'm going to need 12 to the left, 4 to the right. So that's 12 plus 4 is 16. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It's 17. It's 17 and I need what? 16. So I'm probably going to have to call the left margin 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And on the 12th one, I'm going to draw my vertical axis. So this is my y-axis. All right, I need that blue a little bit more prominent. All right, let's work with it. Let's change to black. So this is my y-axis. All right, the x-axis now, the highest value of y is 9. The lowest value of y is minus 7. So that's like roughly half and half. But I need a little bit more space to the top. So I'm probably going to draw my y-axis maybe here. 1, 2, 3, 4, 5, 6, 7. It's too precise. All right, 2, 4, 6, 8, 10, 12. So about here is good. 9 and minus 7. So this is my x-axis, and this is my y-axis. All right, and let's label our axes. On the x-axis, the scale is 2 centimeters to 1 unit. 0, 1, 2, 1, 1, 2, 2, -1, -2, -3, -4, -5, -6. So guys, this is something you have to do carefully because the graph must go out to -6. Understand? To the left, and it must reach or pass 2 on the right. So this must be what? You need to carefully position your axes. 1 centimeter to 1 unit. So every centimeter on the y-axis, the number goes up by 1. All right, so I need to ensure that my graph reach actually at least 9. All right, and down by the bottom, my graph needs to reach at least -7. All right, so now the points are -7, -6. So that will put me about here. -5, 0, -5 is what? -5 corresponds to 0. -4 corresponds to 5. -3 corresponds to 8. -2 corresponds to 9. I think that's my turning point. -1 corresponds to 8. So you see it's coming back down. 0 corresponds to 5. That faces me here. 1 corresponds, I'm guessing, to 0. And 2 should correspond to minus 2 corresponds to minus what? All right, it should be -7. All right, so we made an error there. This should be -7. And over here, it should also be -7. So my graph should start here. Remember the parabola, it's a curve, and when you're drawing curves, you need to draw it via freehand. It's something that comes with practice. All right, so that's a bad start. All right, definitely not perfect, and I want to draw it over because I'm definitely one of those perfectionists. All right, still not perfect, but I'm keeping piece of it. This is the piece that I lost my perfection. This thing hates me. Better. All right, the other half. And as I said, this is something that comes with practice. I'm sure y'all know I'm drawing that over. All right, big problem. All right, you all didn't see it, but I went one too far, 1 centimeter too far to the right. Maybe that's why it was so difficult to draw. All right. So after I draw my graph, I need to label it. This is f of x is equal to minus x squared minus 4x plus 5. Now, after I draw my graph and label it, I'm ready now to answer my questions. We're asked for the maximum value of f of x, the value of x for which f of x is a maximum, and the coordinates of the maximum turning point. So the maximum value of f of x, which is y, is at the highest point on the graph. So f of x max is equal to 9. This is the point on the graph at the highest point. That's where it's a maximum, where x is equal to minus 2. So this is the line, x is equal to minus 2. It passes through the dead middle of the graph. So that line is actually the equation of the axis of symmetry. So these two values, f of x being equal to 9 and x being equal to minus 2, are going to answer several questions, at least 3 or 4. So f of x max, the maximum value of f of x is 9. X is equal to minus 2 is the value of x for which f of x is a maximum. Now, the vertical line through the turning point is x is equal to minus 2. The horizontal line is y is equal to 9. So minus 2, 9 is the maximum turning point. All right, well, the coordinates of the y-intercept, we can get that actually from this, because remember the number at the end is the y-intercept, which is 5. So 0, 5 is the y-intercept. The equation of the line of symmetry. The line of symmetry is the vertical line through the turning point, and we already know that x, that is x, is equal to minus 2 is the line of symmetry. All right, let's see what's coming next. Next, we need the value of f of x when x is equal to minus 3.5 and the value of f of x when x is equal to 1.5. Change the color ink here. When x is equal to minus 3.5 and when x is equal to 1.5. So let's find the point on the graph where x is equal to 3.5 and where x is equal to 1.5. 1.5 is between 1 and 2. So this vertical line here is the line x is equal to 1.5. This is x is equal to 1.5. And this cuts the line, the graph here. I would say here. And this is y is equal to minus 3.4. All right. Next, we need to determine the point on the graph where x is 3.5. 3.5 is in the dead middle between minus 3 and minus 4. That's where you get minus 3.5. You draw the line until it reaches the graph. So that cuts the graph. That cuts the graph here. And all right, let's go again. This cuts the graph here where y is equal to 6.8. So we're ready to answer our questions now. When x is equal to minus 3.5, f of x is equal to 6.8, sorry. 6.8 when x is equal to 1.5, f of x is equal to, was it minus 1.8? Let's go back up and find out. All right. This is minus 3.4. So f of x would be minus 3.4. We need the values of x when f of x is equal to 5. And we need the roots of the function. So first we need to find the point on the graph where f of x is equal to 5. So that's where y is equal to 5. So I'm going to draw the line f of x is equal to 5. So if I want, I could say y or f of x. This is the line f of x is equal to 5. It makes the graph here and here where x is, it makes the graph where x is minus 4. So this is x is equal to minus 4. And here where x is equal to 0. So this is x is equal to 0. So when f of x is equal to 5, y is equal to minus 4. Sorry, when f of x is equal to 5, x is equal to minus 4 and x is equal to 0. So when f of x is equal to 5, x is equal to minus 4 and x is equal to 0. The roots, remember the roots are the x-intercept, which is minus 5 and 1. So x is equal to minus 5 and x is equal to 1 are the roots of x squared minus 4x of f of x is equal to minus x squared minus 4x plus 5. Stay with me. Last question. The interval of the domain, remember the domain are your x values for which x is less than 5. So I think last time we went blue. We went one up and we went blue. So where x is less than 5. Guys, if you want to find out the values of x where x is less than, where f of x is less than 5, we need to draw the line f of x is equal to 5, which I think we already did. So this is the line f of x is equal to 5. We already drew it, but I'm just going to go over it in blue. That is the line f of x is equal to 5. All right, it meets the graph where x is equal to minus 4 and where x is equal to 0. All right, so this graph now has what? 3 regions. Your graph exists in 3 regions of the graph sheet. Above this line, f of x is greater than 5. Below this line, f of x is less than 5. I'm interested in the region of the graph where f of x is less than 5. So this is the region of the graph where f of x is less than 5. Do you agree? You don't have to answer. This is the section on the graph where f of x is less than 5. And for this section of the graph, x is greater than 0 and x is less than minus 5, less than 4. X is less than minus 4. So in the region of the graph where x is greater than 0 and x is less than minus 4, the values of f of x on the graph are less than 5. In those regions of the graph where x is greater than 0 and x is what? Less than minus 4, the value of y on the graph is less than 5. So to answer, x is greater than 0 and at the same time x is less than minus 5 are the values of x, are the domain is the interval of the domain where f of x is less than 5.